All right, let's get into it. Today, we're exploring the machine that literally became the brain of our modern world, the computer. So let's start with a really big question. If you had to name the single most powerful invention in all of human history, what would it be? You know, the one that completely changed how we work, how we talk to each other, even how we think. Yup, you guessed it, the computer. And the journey of how we went from these massive, room-sized calculators to the supercomputers we all carry around in our pockets, well, that's really a story about mechanizing intelligence itself. So, let's dive right in. Our story starts with the very first real attempt to build an electronic brain. Okay, meet ENIAC. This was the world's first general-purpose electronic digital computer. And when I say it was a monster, I mean it. Picture this. It weighed 30 tons, filled a room of 1,500 square feet, and ran on over 18,000 super fragile vacuum tubes. But it could crank out 5,000 additions per second. I mean, that was a speed nobody could even imagine back then. And ENIAC proved this revolutionary idea that intelligence could actually be mechanized. But here's the thing about ENIAC, the big problem. If you wanted to change its program, you had to literally rewire it by hand. It was a nightmare. Then came the huge breakthrough from physicist John von Neumann. He came up with something called the stored program concept. It's this brilliant idea that a computer's instructions, the program, could be stored in its memory, right next to the data. All of a sudden, changing what a computer did was as simple as changing the software. No more rewiring. And that one concept led directly to what we now call the von Neumann architecture. It's a simple blueprint, a CPU, some main memory, and your input/output stuff. And believe it or not, this is the fundamental design behind pretty much every single computer you use today, from your laptop right down to the smartphone in your hand. So that elegant design laid the groundwork, but what happened next was nothing short of a revolution. A revolution in making things smaller and way, way faster. Okay, just look at this timeline. The acceleration is just mind-blowing. We're talking about a jump from 40,000 operations per second with those old vacuum tubes to over 1 billion ops per second with modern chips in less than 50 years. That insane exponential leap was really driven by 3 key inventions. First up, you have the transistor. Invented back in 1947, this tiny little thing was a total game changer. It was smaller, way cheaper, and so much more reliable than those clunky old vacuum tubes. This was really the first big step towards making computers actually practical for anyone. Then, about a decade later, the integrated circuit shows up. This was the brilliant idea of cramming thousands of those electronic components onto one single tiny silicon chip. You can think of it like going from building with individual bricks to using entire pre-made walls. This is what kicked off the whole era of microelectronics. And that leads us to the final crucial piece of the puzzle, the microprocessor. In 1971, Intel managed to put an entire CPU, the literal brain of the computer, onto a single chip. That one breakthrough, the Intel 4004, is what truly unleashed the personal computer revolution. Now, to really get a sense of this incredible progress, just think about this. Back in 1978, an Intel processor had about 29,000 transistors, okay? 30 years later, a single chip had 820 million. That's not a typo. That's a 28,000 times increase in density. It's a perfect, staggering example of Moore's law in action. So think about it. What happens when you can shrink a room-sized supercomputer down onto a tiny chip the size of your fingernail? Well, the entire world gets remade. And just like that, computers were absolutely everywhere. They completely transformed every industry you can think of. Communication, science, medicine, finance, entertainment. I mean, you name it, the computer changed it. It didn't just alter the world, it became the operating system for our entire modern civilization. But there's a flip side to this incredible story. This revolutionary power, it hasn't been shared equally. For every community that's been connected and empowered, there's another one that risks being left behind. And this creates a huge problem, one that we call the digital divide. So what is the digital divide exactly? Well, it's that growing gap between people who have ready access to computers and the internet and those who just don't. And as more and more of our society moves online, this isn't just a minor inconvenience anymore. It's a new kind of exclusion, one that takes existing inequalities and makes them even worse. And the scale of this gap is just staggering. Take a look. In many developed nations, you're looking at internet access for over 80% of the population. But in some developing nations, that number can drop as low as 20%. That's not just a gap, that's a chasm.
So who exactly is getting left behind in this chasm? Well, it's often the people who are already the most vulnerable. We're talking about the elderly, who might have lower tech literacy. Individuals with disabilities, who are trying to navigate a digital world that often wasn't built with them in mind. The economically disadvantaged, who simply can't afford the devices or the high-speed internet service. And of course, people in rural areas, where the infrastructure just isn't there.
And the consequences of this exclusion, they have a serious ripple effect. In education, it makes the achievement gap even wider. In healthcare, it means some people get access to things like telemedicine and others don't. And when it comes to the economy, it creates these massive barriers to getting a job or starting a business. Let's be clear, this isn't about missing out on the latest viral video. It's about being locked out of the entire modern economy. Okay, so the divide is real and its effects are incredibly serious. But is it permanent? What can actually be done? Let's take a look at some of the ways we might be able to close this gap. It seems like closing this gap really requires a combined effort, focusing on three main pillars. First, you have policy interventions. That's things like government stepping in to fund infrastructure and maybe regulate costs to make it more affordable. Second is technology itself, innovations like cheaper mobile devices and satellite internet that can reach remote areas. And third, and this one's crucial, is community and NGO efforts, people on the ground running digital literacy programs and setting up community access points. All of this really brings us to a critical crossroads. What this quote is getting at is that all these digital advancements, they're a double-edged sword. They have the power to either bring us all closer together and bridge this divide, or to push us even further apart and widen it. And that leaves us with one final, really important question to think about. As these incredibly powerful new technologies like AI start to become mainstream, are we going to use them to finally bridge the digital divide for good? Or are we just going to end up building an even bigger, wider one? The answer to that question is really going to define the next chapter of our connected world.